This is Andrew Scaglione. He is with Radio.Cloud. He has been in the network syndication business for quite some time. He has been on TV. He's got a face for TV. I have a face for radio, so it works out real well that way. Noor Hassan was gracious enough to join us. She is with Amazon Web Services, and we'll let her tell a bit more about her vertical, but it specifically deals with what we do. Amazon has made a huge push to serve industries, and media and entertainment and broadcasting is one of them. And we are honored to be the first certified Amazon partner in broadcast cloud. So anyway, so Noor, would you like to fill anything in there that I may have missed?
Hi,
Is her mic on?
Should be ready right now.
Okay,
right.
talk.
Yep. All right. Thank
good.
you for the intro. Very nice to see everybody. I'm Noor. I'm based out of Toronto, and it's actually the first time I came out here, and it's really, really nice. So I'm already hooked. Thank you for inviting me. And while we have a pretty voice for radio and pretty face for television, I'm neither, but I'm here to learn from everyone. So
she's here because you'll get sick of listening to Jim and I after a few minutes, probably.
So
she's the best looking one up there.
right.
Watch him. He is trouble.
Thank you. And pivoting back to the reason why you're here. And I hope it's, we're going to talk about tech. And I'm actually really honored to be here with our partners. So Radio.Cloud is, it is true. They are the first partner with AWS to get certified in the radio space. And so my background a little bit, I come from engineering background, and I've been with Amazon Web Services for 2.5 years. Prior to joining them, I was with Evertz Microsystems. Probably if you are familiar with them. I was on the solution engineering side, working on IP broadcast projects. So I did a lot of work in the compression for distribution and contribution from a pre-sale standpoint. With AWS, I am a partner solution architect, and so I work with ISVs, so AWS partners, focusing on the broadcast area, right? So that's video and audio, and Radio.Cloud is definitely one of them. We have many more, and I'm happy to connect with folks here for questions on that. But my role really primarily is helping partners accelerate their journey in the cloud, so that with your superpowers you can enable your end customers. So end customers would be essentially broadcasters. So thank you for having me.
Thank you.
So Radio.Cloud's actually been around for 4 years. We've been doing this for 4 years. The first 3.5 in Germany. So that's the reason we're gonna. These are some of our clients, but we're going to try not to make this a full-on sales pitch of Radio.Cloud, but we've been doing it for 4 years, so we just want to show you what we know, which is what we do. So to start, I think we want to...
Disclaimer, I like that.
You like the disclaimer? Okay. Well, to start, we wanted to do a little compare-contrast with the traditional automation systems, maybe some pain points of those, and then how we address those at Radio.Cloud.
So with a traditional automation or playout system, there's an investment in hardware and there's an investment in software. And the hardware eventually wears out. It becomes a disposable item at a certain point. And that's kind of a thing we want to try to stamp down a little bit. Software costs, obviously, are going to be for us and for a traditional system. But for us, there is minimal hardware. We actually will allow you to use pretty much anything on which you can get a browser, pull up a browser. We are software as a service, so you really don't have to buy anything if you have a browser. you'll be able to use it. And I think one of the key things that's overlooked in a lot of cases is sustainability. We don't ask you to invest in heavy hardware that's going to be obsolete after several iterations of software. So we think that sustainability should be probably a little further up the line. So that's going to be something that we'll all take a look at in the future.
Yeah, and we say minimal hardware. We'll let you guys pass this around and look at it. This is really all we need to actually, generate the signal to go out over the air. So Jim's going to pass that around.
That to Jeff there.
We call that the Edge Gateway. That one's made by Seneca Data, which is an aero company.
A lot of you are probably familiar with Seneca Data because that's what a previous automation system that I was associated with for many, many years used as the platform.
So another traditional pain point, of course, we're all familiar with the updates and manual updates, and sometimes multiple times a year that you have to do to software and firewalls and different things. With Radio.Cloud, because everything is web-based, browser-based, all of the updates and the new features get deployed in the cloud. So oftentimes you wake up, you log in the next morning, there's a new feature there, and no downtime and no skin off your back.
So the interconnection between locations, I think, has been brought to the fore with COVID, where we have interdependencies with locations and where talent may exist. This is something that you have to kind of map out generally, and sometimes it can be a little more difficult. But with Radio.Cloud, everything's connected through the cloud. There's a common point there. So anytime you can access a browser again, you can create content up to the cloud and back down to where it's going to be consumed.
So when we say localization, we mean taking a 24/7 network or a syndicated show or a format and inserting positioning statements, local imaging, different things like that. Usually that's done at each location, on site, more of a manual process. That's one of the real powers of Radio.Cloud and doing broadcasts through the cloud, is that you can really hyper-localize, ultra-localize these stations automatically, whether it's 2 affiliates, 200 affiliates, everything's just kind of done, pulled from an archive in the cloud to make each location sound like that's where the show is actually originating from. So with increasing feature sets, typically it takes a little more horsepower to pull those things off. With Radio.Cloud, all the heavy lifting or the complex features are in the cloud. And we'll talk more about how that's executed in just a little bit, or Noor will. Yeah, so now we're going to hand it over to Noor just to give you guys more of a background on what we're doing in terms of a cloud native approach versus some of the other terms you're used to hearing, containers, virtual machines, kind of how that all works in a broadcast landscape. So, Noor?
Yeah, sure, thank you. So starting with migration methods, right? There are various ways how partners and customers can bring their workloads to the cloud. And if we were to divide them into a couple of categories, there is the migration path, and then there is the cloud native path. And so choosing the right one really depends on the workflow requirements, it depends on the organization requirements, time constraints, priorities, so on and so forth. But when we look at migration for a moment, you have probably heard terminology like lift and shift or refactoring and so on. So, and again, within migration, these different ways of doing it really depend on the customer requirements. And so at AWS, we work backwards from there, and then we enable our partners and then hence customers to do what's right for them. So lift and shift is a very popular example. The concept of a lift and shift is really taking the application as is over a virtual machine and just putting that in the cloud, right? And so there is no re-architecture of the application that takes place. There's no optimization. There's no modernization that happens. And usually customers or partners resort to that when there is timeline limitations. So because it is the fastest way to get there, right? So if there's like an immediate need, let's say to spin up a disaster recovery, for example, right? That's one way. Now, refactoring is another example of a migration whereby you are modernizing that application. It takes a re-architecture of that application so that it is optimized in the cloud. And we'll talk about that in a minute, which really means leveraging cloud-native services or managed services and microservices to be able to perform best through your application. And so with Radio.Cloud, that kind of takes us to the cloud native. And so in cloud native, you're not actually migrating that application. It is born in the cloud. And that what that leads to is really talking about leveraging these native services in the cloud. Why is that important? Because for one, it takes away from the work to migrate from on-premises to the cloud, right? So that's the first thing, because that in itself is a journey. And then the other thing is cloud services have been engineered in an optimal manner, if you think about it. And the idea is to present users, so consumers of these services, so whether that is, engineers or whether it is data scientists, or it really doesn't matter. The idea is that you don't worry about undifferentiated heavy lifting of the underlying infrastructure. That's really the core of it. Because again, you're not having to worry about maintaining compute, for example, right? If you need a database, then you have a number of databases that fit the application, whether it's a SQL, non-SQL, so on and so forth. If you need storage, again, you don't have to worry about the underlying compute to make that happen or scaling it manually as your library grows, for example, right? You're essentially relying on these managed cloud services. The key aspect or the key advantage of that is, first, it allows you to innovate. Why? Because you are essentially focusing on the application. So now, a Radio.Cloud crew can now focus on optimizing what they do best, which is the radio aspect. So the radio processing side of things, right? And which means that customers are accelerated faster. And that's really the idea. Another one is sustainability, like Jim touched on, which is really important because you are optimizing on these services and you spin them up and down when you need them. It's not turned on 24/7 if you don't need it, right? So there's a lot of saving in that area as well. And that also touches on cost from a saving standpoint, right? Because you are essentially paying for these services when you need them, and they are fit for your application.
Yeah, and this is just a glimpse kind of behind the scenes. As a user, as a station or a network, it's a SaaS model, so you guys get the login, you get the platform as the website, and you can access it anywhere. But this is just kind of how it's being run, why it's a cloud-native approach.
So some of the considerations when you're thinking about how you want to approach some of these aspects would be security, and I think that's been talked about enough today to satisfy everybody. But consider that Amazon has some of the best security in the world. With military, defense, government relies on Amazon to make sure that everything is safe and secure. And the safety is guaranteed stability, meaning it's going to be there, or there's a quick backup recovery available to you. And these three things you'll hear a lot about when you talk about things in the cloud is durability, and that means those things will be there. It's not they don't wear out, it's just that you have them there. Availability means the ability to access those things, and that's system uptime to make sure that you can get to it. In reliability, and all these things are measured in nines. I think you've probably heard, 5 nines or 6 nines or whatever. That's kind of how you look at those things. And reliability means that the system is probably working as it's intended. So, or the probability that it is. Anyway.
So one of the things we really like is this definition from the Cloud Native Computing Foundation, and it's just different aspects that really apply to our approach to using the cloud. So we called it a formula, and it includes that infrastructure that we've been talking about with AWS, microservices, which we'll touch on a little later. Some of those microservices being housed in containers, which we've heard about today, and how scalable they are, and you can switch them on and off as needed. Continuous delivery, so we're web-based. It's always available for you as a user wherever you are. And then ongoing development. So we actually have a full-time DevOps team of about 20 people. And the system, as you see it today, is going to look completely different a year from now, because whether you're a user giving us ideas of new features or someone who just signed on, you're going to get access to all of those features as a SaaS model.
So I'm not sure that addition is really much of a formula, but if you could reveal the answer.
Yeah, well, what that means is that you can run maximum applications on minimum servers, which is attractive in a lot of instances. So now we're going to start to give you just some practical examples of how we've employed these cloud-native methods and infrastructures over the last 4 years. So just overall, what is Radio.Cloud? It's the first to market full-time cloud-native, not only a radio automation system, but also content management and a production platform as well. And like I said, 4 years, already 160 affiliates, most of those in Germany, a handful of them around Europe, and another handful in the US, but available worldwide now. And it's good because we can interface with existing not only automation systems, but traffic systems, music scheduling systems. It's a very flexible product. And as of spring this year, we support live programming along with the automation side. So between that and then the way we can network and do localization, that's kind of the true power of Radio.Cloud. So as a user, very briefly, this is the interface you would see. You would upload your files via FTP. You would have the ability to voice track in the web browser. Content management system, the playlists, or the live platform, everything eventually gets sent down to that edge device that you guys are passing around, played out over the air on the transmitter. What's actually happening in the background, which Noor's going to touch on here a little more, are some of the services we're using through AWS.
Yep, absolutely. In terms of the services, right, the intent here is not to really dive deep into each service individually. We're happy to answer questions afterwards on each. But really the idea is that these are, cloud native services. They are managed. Managed meaning they are managed by AWS. And so you really, again, don't have to worry about the underlying heavy lifting of really managing that compute and maintaining it and so on and so forth. And so these are some of the services that Radio.Cloud are using. And so to kind of highlight some of the ones that stand out, like AWS Lambda, for example. Right?
It's not a COVID variant, by the way.
No. So it existed a long time before that. And so Lambda essentially enables you to bring your code and instantiate functions through an event-driven architecture, right? And so let's say you are wanting to do a transcode job, right? You can actually have that in a Lambda function, which gets triggered by an event. An event is a change of state, and so that could be, let's say, having an audio file in storage. And that is going to trigger your Lambda to execute on that transcode job, and that's it. It will shut down after, right? And so, and again, that is event-driven, which will then trigger downstream events as well. And so it is ideal for, short-lived events, or if it's ideal to integrate into a microservices architecture, and so on and so forth. Amazon S3 is the storage service, and there are various tiers for that storage, right? Depending on your needs, you can use it anywhere from instantaneous retrieval to archivals, right? And as you can imagine, the cost would drop with the archivals. Amazon Transcribe, so it's the last one I'm going to touch on right now, but really that one stands out for me because it ties back to the whole concept of cloud native and what enables you to do faster. So Amazon Transcribe, right, is a managed machine learning service for transcribing audio and text. And so the idea here is that you don't need a machine learning or a data science team to actually work with services like that. It is fully managed. It is actually built for users like even myself, who I don't have that background, to essentially start using it immediately, right? And so that allows innovation because the team talked about localization earlier, and that's like an increasing market demand at the moment. And so how do you do this faster? So imagine having to build a service like this and kind of build it in-house or develop it yourself. Not to say you cannot, it's just how much cycles would you be spending there versus actually leveraging something that is ready-made immediately for the application.
And that's a great transition because now we're going to show you, we call them 10 Radio Cloud highlights, but the first one is our web-based voice tracking module, which is where the transcribe or speech-to-text, some people call it, kind of originates from. So what we have here is...
You've got the laser.
Yeah, the laser pointer, right. Keep everyone alert. But so with our web-based voice tracking module, like many others, but just a little different from some others, we give you the ability to see the previous song, the upcoming song, to produce as far ahead as you want with these hours here. You got your calendar. And then my favorite part of this, the ramp, which is the intro or the post of the song. We allow you to set every voice track that you want on the ramp, but Radio Cloud's going to mix that automatically. So it's going to sound like your jock is hitting the post every time, whether it's a long voice track or a short voice track. And this is a great tool because it's web-based. You can access it anywhere for the jocks and the content producers, for programmers and ops managers and people keeping an eye on the status of their station. We have this voice tracking status tracker, which is basically a log of how many tracks have been produced for a specific hour in a specific day. And it's a whole grid, so you can see at a quick glance, green means everything's produced, the other colors means maybe there's a few left to be produced. But I really want to focus on this middle pop-up box, which allows you to see not only the transcription, who produced it, how long the track is. You can click the play button and listen to it as if it's an air check. But then you're also able to share content between multiple stations. So in this example, we'll say format F1 and F2, or music format 1 and music format 2 this is one of our customers in Germany. And what they're able to do, instead of having 8 voice tracks for the 2 stations, because it's 4 tracks an hour for one, 4 for another, they can share this content. So 3 of those voice tracks in this example are going to be the same across both networks. 1 is localized, so suddenly you go from producing 8 voice tracks to producing 5 an hour, just in this example, and saving that time because, who wears multiple hats in radio? Everyone that works in radio. So if you can save even a little time, and it's over a 4-hour shift, that's going to give you a little more flexibility throughout the day.
So this is our live screen, and we talked earlier about being able to do anything from anywhere. We actually have integrated the ability to have other people appear on our graphical interface and audibly at the click of a button. So if we have somebody that's 30 miles away, 3,000 miles away, it doesn't really matter. I should say kilometers, I guess. I was going 100 kilometers an hour, and I thought, gosh, this doesn't feel like it, but it's it was exciting anyway for an old guy. So the microphone is up here, and thank you. If you click on that, you can assign that to somebody at a remote location if you'd like to. Well, Andrew is actually remote in that case. You can click on another one.
You can have a laser too.
Ah,
Wow.
on guard.
Watch out, everybody.
Yeah.
Hide your eyes.
All right. So mic 2, you can assign to Kirk. Mic 3 to Brad. And if you want to, you can bring in a phone call from somebody that isn't online or whatever. You can call them and bring them up too, and have a collaborative program virtually instantaneously with just a few clicks of the button. So anyway, this one is really straightforward. These are our mixers. We have 3 modes. We have manual. We have a live, and we have live assist, and you've probably seen those in several other playout systems. This is the list, the playlist. In full automated, it loads each player and keeps refilling the player. If you happen to have a console that has motorized faders, we can control it. We can do this with each fader remotely if we want to. If there's a studio facility that has a fader that is motorized, we can control it. Anyway, so.
Of course, the big topic is latency, right? So for our automation system, latency is not going to be an issue. For the live system, it's also not an issue. There's only one time when it's going to be an issue, and that's if you're recording, if you're live on air, and you need to hear your own mic audio in your headset. And in those cases, we just have an external device in the studio or on site to kind of route your audio from the cloud to the device and then back to your headset.
Listen to the program channel, essentially.
Yeah.
As opposed to the air chain.
But otherwise, it's pretty much the latency's undetectable, which is pretty amazing. And one of the reasons that is we have, through AWS, we're running on multiple different, in multiple regions with multiple availability zones. So say we have, one on the East Coast of the US, one on the West Coast, a couple in Europe, and a couple in Asia as well. So it's really a global infrastructure, and no one failure, no one endpoint of failure is kind of the point of that. And you can see on the map, just to kind of bring it relevant here, there's 2 zones in Canada, or 2 regions in Canada. One of them is kind of in the metropolitan Montreal area, and the other one's coming soon out west. So it's an always expanding infrastructure for AWS.
So this is the content management portion of the screen. It does pretty much what you'd expect, be able to go through the library and take a look. I think I should stand in front of the screen because Brad's taking pictures back there, but that's another long story. We'll give you the presentation. So you can search through the library. You can select anything you want, drop it in the playlist. The complete library is there. You can also upload audio. I've got the little thing right there. You can upload audio. Oh, you kept that slide. I didn't know that. Directly into the system from there if you want, and it gets migrated to the cloud, and it's available for you instantly. And just to give you just a little backside information, when you use things here and you want to listen to them, they're in a data-reduced format, MP3. But we will play natively WAV or uncompressed, whatever you want. If you want to do 48K, we'll do 48K. It doesn't matter. But we split the libraries in 2, one for fast retrieval and auditioning, and the other for actual playback, so you don't lose anything whatsoever. Anyway, one other thing that's somewhat unique with the way we approach things is we don't do stretch and squeeze. We give you multiple cue-in points, multiple intros. We can do hooks in and out. We have multiple EOMs, meaning you can enter a song at a time that's acceptable to your music director. You can get out at a time that's acceptable to your music people. Just imagine, "Hey Jude," how many na-na-nas would you like to listen to? That's kind of the universal response there. So we can do that and make sure that you maintain your music integrity.
So our clocks are very interesting, but the main thing to note about them is it's a drag and drop functionality. So everything from over here, you can just drag into the middle, and that's going to generate the clock over there. Of course, we interface with Music Master, Selector, all the existing scheduling systems as well. But if you need to edit or build a new clock, it's very easy. You can build them as simple or as complex as you like. So this is a real clock in Radio.Cloud from one of our German affiliates. I counted them. It wasn't fun, but it was 91 elements in that hour. And it looks like it's off, but it's actually not. That's just how much overlap this one station does, and it works. And then we also have the ability, like we said, to localize. So this is the main clock right here, but 17 stations are running variations of that clock, whether that's longer local commercial breaks, different spots for inserts. This is the power of Radio.Cloud to localize one clock for many stations and have it sound seamless at every location. And then for an example in the US, we have, we'll play some audio, but basically what you'll hear is a localizer that's coming straight from our archive. It's going to say, gotta have my Sunny 95, and then it's going to go right into the network voice track, which every station is going to get, which will start with my name is and the host's name. So hopefully this doesn't blow our ears out. Let's take a listen.
Gotta have my Sunny 95. My name is Tony Larino. If this is your first time here, welcome to a radio listening experience we can all enjoy. It's very simple.
And so both of those are set on the ramp or the intro of the upcoming song. So it's just mixed very smoothly, and that's kind of an audio example of the real power of our software.
So we talked about Amazon Transcribe, and what we do is listen to what is said, and then we'll print it out so that you can do it for voice tracking, air checking, whatever. But Amazon Transcribe does that for us. More of the power of the cloud. And we're running over here, buddy. I talk too much.
So very quickly, we also give you the dashboard to monitor. It's like a self-monitoring tool. You can take a look and quickly see for your stations, do I have my music logs, my traffic logs uploaded for the next few days? Am I missing any audio? Knowing that Radio.Cloud's also monitoring through a couple different softwares. We use one called PRTG, one called New Relic. And what those do is give us the ability to proactively monitor the software, see if anything's going to become an issue in a few days, and then if it is, we can either address it or notify the client and say, you're missing a playlist, maybe you're missing a few files here and there, but that's where the proactive monitoring comes into play, is nothing actually becomes an issue because we're able to kind of track the whole system.
So one other thing we have is access to social media. So if you click the, that's the Twitter icon, but you'll come up with Wikipedia, you'll come up with Facebook, what else? Twitter and Instagram. So if you need to say something semi-intelligible about an artist coming up or an oldie or whatever, and this is all oldies, you'll have some reference things that are fresh. Maybe.
We've mentioned microservices a few times and how they really beef up a cloud-native infrastructure. So, Noor, if you want to just give a quick overview on microservices.
Yeah, sure. So kind of bearing time in mind, if you think about it at a high level, right, it is having loosely coupled functions in your workflow. What does that mean? It means that to what it makes sense, you would want to have independencies between functionalities because that enables you to iterate quickly on them. It essentially enables your various resources, like the development teams, to actually develop in parallel, right? And also allows you to innovate on each of them separately, right? So that's really the idea of microservices. So when we talked about some of the managed services before, at a high level, we talked about databases, right? If you think about it, let's say for all these files that you are storing, you want to have an indexing system. So versus combining that indexing system with your storage in the same application, an easy example would be to decouple these and essentially leverage a managed database to handle that for you, and then have your storage service store the files, and then essentially you have microservices, and then you can connect them through whether it's messaging buses or event-driven architecture that we touched on before. And I know that you have examples from the radio side where you were able to decouple some of these things. So back to you.
I think one of the best examples would be just audio transcoding, which, Jim, you already hit on, in terms of when a file is uploaded, we're going to take that and maybe compress it into an MP3 or an AAC. So when you're actually in the interface and you want to preview something, you can preview it instantaneously, whereas we're actually going to play out the full quality WAV file or whatever you're using. So that's one of the main examples of how we use microservices. But overall, we've been around for 4 years in Germany. We had our first station in the U.S. last Labor Day, so coming up on a year now. And we've already, just from the sound and the localization of it, they came back to us a couple of weeks ago and said, you took us from outside the top 10 to inside the top 5 in the market. Local sales have been up for us. And we really didn't start marketing and offering Radio.Cloud in the U.S. until the NAB show this year. So we're on pace to have about 100 affiliates within the first year, starting April 2022 to 23. And that was one of the reasons why we were very fortunate to be honored with a couple of awards at the NAB show in April. But the reality is that we're the first completely cloud-native content management production automation platform. It's possible. It's here. We really can run a full radio operation out of the cloud using a cloud-native architecture, leveraging the power of AWS, which is, we wouldn't be here without AWS. So.